That wasn't a joke.
Are you staring at her? Yeah. Sit down while I do this.
Does he like that or not? Oh, I got a paper.
We're the only ones that.
Trash.
No.
All right. Would you guys like a quick number talk? All right. This is not an estimation number talk. This is a number talk that's going to be helpful for today. So I'm going to put something up on the board, and I want you to figure out what it equals without the use of a calculator. Don't shout it out. Let people think about it. It's not 4.
Oh, without a calculator.
Do you use paper?
Okay.
Yeah. Which means you shouldn't have to actually figure out what 10 times 4 is.
Oh, yeah.
Okay. Anyone think they know what the answer is? Just give me a thumbs up if you think you know.
I should have got both of them.
Everyone know?
They all fell out of it.
All right. No, what's the answer? 10. Why is Noah right? All right, what's 10 factorial? Oh, okay. So Sean's going all the way to where I would like to go eventually. But if you thought about this, I should have chosen a smaller number. 9, 8, 7, 6, 5, 4, 3, 2, 1. All right. So do you agree that literally everything's going to cancel? But Sean said something cool. Sean, what did you say about 10 factorial? So this is 10 times 9 factorial. So I could collect all of these up as a factorial, all of these up as a factorial, and then I could cancel them all at once. Great. All right, extensions. What's your favorite number? That's a terrible favorite number. 11. That's too big. Sorry, too small. 6? You know what my favorite number is? E. Because it is my favorite number. All right, without a calculator, figure it out.
What is my favorite number?
E.
I like that one.
All right, anyone think they know what this one is? What?
30.
30. Why? How'd you get that?
5 times 6.
Okay, so the 4 factorials would cancel. We're left with 6 and 5 from the 6 factorial. All right, so we're going to do something similar to that with n's in it today. So here we got 6, 5, 4 factorial, 4 factorial, 30. All right, so let's roll to the notes. So we are going to be talking about ratio tests for the majority of today, and then we will hit something called root tests. I will say their conclusions are very, very similar. So let's look. We've got a series with non-zero terms. That's important because we're going to be dividing. Now, I get the vibe from this test that it's very similar to limit comparison, but instead of comparing to another series, we're kind of comparing the series to itself. So what you'll notice is that we are taking the n plus 1th term and dividing it by the nth term. How we're going to find that n plus 1th term is exactly how you would like to. We're going to plug n plus 1 in everywhere there's an n. So you'll see what that looks like in a second. We're taking our same limit that we know and love as n approaches infinity. We're taking the number of terms to infinity. And we are yet again comparing to our favorite number, 1. Here we want, since we want the terms to be getting smaller, we want that n plus 1 term, when we divide it by the nth term, we want that to be smaller than 1. So if we get less than 1, we converge, greater than 1, we diverge, equals to 1, our test fails. We know nothing, we have wasted our time. So I'm going to show you one today of kind of what you would want to avoid using this test on. You'll see what we mean by that. Also, what do you notice is around our ratio, around our fraction? Absolute value bars. So one kind of cool conclusion that comes out of this is if I use ratio test, if this thing converges, it also converges absolutely. So we talked a little bit about that last time with alternating series tests and absolute versus conditional convergence. That's just kind of a cool conclusion, not really super necessary for what we're going to be doing with this today. So let's begin. Before we even start writing, I want to just peek at, hi, how was your SOL? Lovely. It's a great time. Before we even get started, can you just scroll through the first 3 problems? And I want you to tell me what types of functions do you see in these problems, the first 3 of them. So we got 2 to the n over n factorial, n squared 2 to the n plus 1, 3 to the n, n plus 1 factorial, 3 to the n. What kinds of stuff do you see? All right. We see fractions, definitely. I see a lot of what I would call exponential functions. So like 3 to the n, 2 to the n. Those are going to be really, really good for ratio tests. Also something we haven't seen a lot of yet, but we will see a lot of for ratio tests. Make math exciting again. Factorials, if you see factorials, welcome to ratio tests pretty much. And that's because they're good for canceling. So let's start. I am going to start. Like limit comparison tests, I'm going to show you this first step one and probably only one time because it's a bit aggressive. I'm going to take, we'll roll with it. We're going to take the n plus 1th term and divide it by the nth term. Now, I'm only going to show this step one time because it's going to be a fraction over a fraction. Normally, I'll start with first fraction, flip it, reciprocal. Was that a picture of me? No. I don't like that. I got posted on social media once and it was rude and mean. Yeah. Was it? No, when I was a teacher at my old school, they were mean people. Monticello High School outside of Charlottesville. I would prefer not to say. All right. So,
We need to square up. Where are they?
They're like full-on adults now. It's my first year of teaching. All right. So, see where that n is? I'm going to put n plus 1. Wow. Because I'm finding the n plus 1th term, this guy right here. So we're going to do this every time. All right. What do you guys think? Instead of n factorial on the bottom, what do you think it's going to look like? N plus 1 in parentheses factorial. All right. So notice everywhere there's an n, it's like I'm substituting n plus 1. On the bottom of this fraction, I'm going to copy down the nth term. So just the thing that is inside my series. Now, this looks stupid. I don't want it to look like this. So I'm going to usually start at this next step. Just like limit comparison tests, I'm usually going to keep the first thing as is and multiply by the reciprocal. Miss Hepsy, do I have to keep those absolute value bars in every step? Yes. Because we're comparing to 1 at the end, so the sign really does matter. All right, so I'm going to have n factorial on the top here, and then 2 to the n. One of the reasons I particularly like this series test is you get to kind of turn your brain off for this part. You just get to write that guy upside down. All right, now, in the next step, our goal is going to be to break some of these things apart. And it's going to be relatively similar in every ratio test question that we do of how we want to break these things apart. Our goal is eventually going to be to kind of cancel some of these guys So when I'm figuring out how to break stuff down, I'm kind of looking over here for a little bit of inspiration. So let's start with the 2 to the n plus 1. How do you guys think I could break that into 2 pieces? Perfect. So I'm going to take that top piece and I'm going to make it 2 to the n times 2 or times 2 to the first, if that one helps you. Now notice that's going to be advantageous because there's a 2 to the n at the bottom of the other fraction. All right, let's talk factorials though. So I'm going to go back to where we talked about where Sean made his cool discovery about the 10 one. All right, so notice here, I could break off this first piece and then collect the rest of them as like 9 factorial. So let's talk about the same thing with n plus 1 factorial. I would start with n plus 1, and then what would the next thing in the list of factors be? How do I get from 10 to 9?
Oh, -1.
Minus 1. So what's n plus 1 minus 1? N. And then I could do n minus 1, n minus 2, n minus 3. But, oops, 3. All right. I could keep going all the way down to 1, but I want to use what Sean said. I have in my fraction, I have an n factorial there. So would you agree with me that I could take n plus 1 and collect the rest of them as n factorial? So I'm going to count down until I see the one I want to match with, and then I'm going to collect the rest with factorial. All right. Mr. Brown's really loud. On video now. All right. Now's the exciting part. What can I get rid of? All right, let's call this 2 to the n power. All right. How exciting. This has become so much simpler now. We have the limit as n approaches infinity. On the top, what are we left with? On the bottom, what are we left with? I think now that I can probably figure out where this limit goes. All right, I am also convinced. 0. I'm taking 2, dividing it by something that's approaching infinity. Bottom's getting real big, top's not changing, so I get 0. All right, so now, like our other convergence and divergence tests, usually we produce a number. So we're kind of at that step of like, why do I care about this number? Anyone think they know why they care about the number 0? This one is less than 1. So what is my conclusion using our chart at the top? We converge by ratio test. So it's kind of like limit comparison test, except you don't have to choose another series to compare it to. So I like to think of this as kind of limit comparison test where you're comparing the series to itself. So it's got a very similar flair with the fraction part of it, the fraction setup, but this one we're producing from the actual series. So we're almost comparing it to itself. Yes. So we're always going to do the n plus 1 term to the nth term. All right. Yep, exactly. All right, so let's just practice this again. The only thing I can really do is just make this series term more complicated, the nth term. I would like to point out that I think ratio test does a good job of some of these series tests. I don't know about you guys, but like the limit comparison test, I kind of know the answer before I get started. When I'm looking at one of those, like 1 over n to the 7th plus 5, I'm like, okay, I know that converges. Let me just find the work to there. But for something like this, you might not be convinced at the beginning whether you know something converges or diverges if we kind of have a complicated series term like this. So I think this is a good test for the first time where I'm like, I really don't know what this is going to do straight away. Anyone want to put money down? Converge or diverge? You think diverge? You think converge? All right, we'll find out.
Yeah, thanks.
All right. Look, I know the 3 to the n grows faster than the 2 to the n, but does the n squared make up for it? Who knows? So, are you guys cool if I start here?
Yeah.
All right. Let's figure it out. So, what's n squared now going to look like? and I'm going to use some parentheses, right? So everywhere there's an n, I'm putting an n plus 1. Oops, trying to color code. All right, let's talk about this guy. This is the more interesting guy. I understand why your eyes went there. So we want to plug in an n plus 1 where that n is. So that exponent should look like n plus 1 plus 1. How would you write that? N plus 2. All right. The only time it would be different is if it were like 2 to the 2n plus 1. You'd be doing 2 to the 2 times n plus 1 plus 1. So if you had multiplying, it would get a little bit weird, but usually you're just adding. All right. N plus 2. All right. On the bottom, what's it going to look like? 3 to the n plus 1. All right. Not done yet. What am I going to multiply by? Yeah, take that, flip it. Don't think too hard. 3 to the n. No. That was good. That was good acting right there. You actually looked distressed. Most likely to get an Oscar. No, Creighton. Has everyone voted? There are some of them that are so close right now.
There should be more.
Most likely to win an Oscar. I don't remember. No one nominated you.
I have no, like for some of them, I have no.
I didn't know what was going on.
Why do I put out so many announcements and post on the Schoology page if y'all aren't gonna read them? What would be the best way to reach you as a seed? I do. The disrespect.
I'll start checking it now.
You'll start checking now? Thanks. It's literally at the top of the page. Yeah. One of them was tied this morning.
Which one? Yeah.
Forget. I don't remember. Best Smile has been close the entire time.
Yeah, give me a smile. Oh, really?
Yeah. Okay, actually, anyways,
Okay.
it's still like really likely that just as everything I'm supposed to tell our teachers.
Okay, that's cool. Yeah, just if you need to go, you're more than welcome to. All right, we're back up. We're back running. I don't know. I got a new computer and now it does that sometimes. It was just concerning. It might be that I'm trying to do like a Google Meet and this, like I'm asking it to do too much, but I'm still gonna ask. I know. New computer. I know. All right. I need help up here. All right. I'm going to tell you that the n plus 1 squared is not going to do what you want it to do, so just leave it alone for a second. All right? We might foil it in a minute, but we're going to leave it as is for right now. Thoughts on the 2 to the n plus 2? How would you like to break that down? There's kind of two good ways to do it.
And 2 times 2.
All right, so we could do 2 to the n and then 2 squared or 4. Some people in my other class noticed that this 2 to the n plus 1 is at the bottom. So another alternative, you could break it into 2 to the n plus 1 times 2 to the first. So you have the n plus 1, so you can cancel right away. I see some people shaking their head. Either one's fine. So let's try the way the Emory and the back ladies seem to like. We'll do 2 to the n and then 2 squared. I'm just going to leave that 2 squared unsimplified, partially because I wrote 2 different types of 2s, and that's fun. Hold on. I'm just not done yet. All right. How would you break up the bottom? All right. Gonna copy this guy down. All right. Since we chose to break out 2 to the n on the top, I'm gonna break this on the bottom into 2 to the n and 2 to the first. All right. Happy go lucky cancel time. What can I cancel? Yes. What? This guy? So I did 3 to the n times 3 to the first for the 3 to the n plus 1. If you want that 1 there, you certainly can put it there. All right. Anything else? Yeah, I would cancel one of the 2's personally. So take away this squared and that 2. So you're doing essentially 4 divided by 2 there. All right. Let's rewrite. Kind of. So I'm canceling one of the 2's.
Oh, okay.
That was just my shorthand for doing it. All right. So I have the one of the 2's and the n plus 1 squared. And then on the bottom, I have a 3 and an n squared. Now, personally, I think I know what this limit equals right now. Anyone else think they know what this equals right now? Yeah. But let's try to multiply it out just to make sure. Now, wait, before I forget. N plus 1. All right, we're gonna play sit, stand, hover. All right, I'm gonna write a statement. If it is true, I would like you to say seated. If it is false, I would like you to stand up. If you don't know, hold squat. You get to hover. As an example, let me demonstrate hovering. This is what hovering looks like. Because you should know. True. True, sit, false, stand. False stand. All right.
No, that is.
It is wrong. Good. All right, you may sit.
No 2n.
Ah, Nina said 2n. What does she mean? What does she mean? Yeah, I have to actually multiply this out. So there should be a plus 2n in the middle. All right. I will tell you guys a lot of the mistakes that I'm seeing on this like set of problems when we did our note check in my other class, they were just algebra problems. Everyone knows how to do the convergence divergence part. You just like mess up the algebra.
No, I was looking at Nate's reaction.
Oh. All right. So I'm going to distribute the 2 into that. So I'm going to have 2n squared plus 4n plus 2 all over 3n squared. All right. Are you ready for another round of sit, stand, hover? Yes, you may. All right. I'm about to do something. If I'm allowed to do it, you may sit. If I'm not allowed to do it, you have to stand. If you don't know, get your quads ready. All right, are you ready? All right, so allowed, hang out. Not allowed, stand up. Allowed, sit. Not allowed, stand. Y'all better get your butts out of that chair. Do not do that. Stop doing that. No, get up, stand all the way up. That is not allowed. Not allowed. Stop canceling things when people are adding and subtracting. So you may sit now, but that was the biggest mistake I saw on the notes check for my second block. So we're going to talk about it. If there is addition in the top there, do not cancel those things. That is not legal. All right. Let's talk about what this limit equals, though. Anyone think they know now what this limit equals? 2/3. You should, if you do not know how to do that limit at this point in your calculus career, get some practice in because we need to know how to do that limit. We have same power, top and bottom. We're going to infinity. That's going to 2/3. All right. Now that we've talked about this so much, why do I care about that number 2/3? We are less than 1. All right, this is not end term test. What test is this again? Okay, so I know it's bi-ratio test. What's my conclusion though? Converges. No, I just like capital R's better than lowercase ones.
Bothers me.
I used to write my lowercase r's as just smaller uppercase r's. And then I taught unit 7 with the pi r squared minus pi r squared, and one of my students was like, you have to stop that. Because it just looked like pi r squared minus pi r squared. All right. You guys want to try one? All right. I want you guys to try this one on the back. Very, very similar to what we've been doing. We already dealt with an n plus 1 plus 1. We already dealt with a 3 to the n, plugging in the plus 1 there. I'm going to give you 4 minutes. No, not 54 minutes. Good Lord. I'm going to give you 4 minutes to try. And then I'm going to start writing up some of my work. All right. If you get done before that 4 minutes, if you're fancying yourself a brilliant human today, I'm going to tell you the next example is going to be the example where ratio test doesn't work. Maybe think about why, or like what types of functions ratio test would be bad for.
Are you surprised?
Why do you need my phone?
My knees make noises now. I have the worst knees ever.
There we go. I'm back already. Enjoy this class. Really? Moderate to mild levels of go into this class. High on days I'm gonna do.
Look at you go. Yeah, all of it. Make this test your test. No. Where are your limits? If you give up notation, great. I've got the same thing. What would happen if you just work? Yeah. So I would get what is it? Right, so I would start counting down on that guy, kind of like in the report. I need you to break down. Remember how we did that one? The n plus 1 times n factorial? Yeah. So let's start counting down. I would have n plus 2 n plus 1. I have an n plus 1 factor there, so that's where I would stop. So I would do n plus 2 n plus 1.
Factorial. And would it be n factorial or just?
So you could count down to n factorial, but then you probably want to count down to n factorial. So I usually count down until I get to the string.
So multiply them both out?
I don't know what that means. You don't agree with that statement?
Without the n.
Yes, I agree. Hey.
How did you do that?
I like that. Times 3.
Times 3. What? How did you do that? Two factorial.
I did, instead of doing n plus 1 plus 1, I did n plus 2. And then I started with factorial, so I did n plus 1, and then I did factorial.
Gotcha. Is it n plus 2?
If you can find that way, you could stop at n plus 1 factorial if you want. Also, where you're at.
No.
Oh.
Oh,
Is that a solo?
Oh, yeah. Okay, so what now?
Think about what you're plugging in.
No way. No way.
Infinity plus 2 on the top, that equals infinity. Wait, is the answer gonna equal infinity? Like,
All right. Let's talk.
Oh,
Because it's because that's N plus 1. We broke off the first. We collected the rest. So we're gonna do the same thing on this side. So N plus 2, what would the next one? Infinity.
Oh,
I don't know yet. Or do Yes. All right. You guys ready to talk about this? All right. Even if you haven't gotten to the end, let's start to set this up and get going. Again, factorial I know is something you guys haven't played with in a long time, so we're gonna do a lot of it because Taylor Series has it all over the place. All right, so in the top, we've got n plus 1 plus that one that's there. So I've got n plus 2 factorial. In the bottom, I've got 3 to the n plus 1. Flip it and write down. Now, there's a few ways to deal with the factorials here. What I like to do is start counting down until I get one that matches. So I have n plus 2. To get the next term, I subtract 1. So this would be n plus 1. Now, I could keep going. I could do n. I could do n minus 1. I could do n minus 2. But that's getting aggressive because the one in the bottom right there, that's n plus 1 factorial, is this times this times this times this times the rest of them. So what I would like to do is whenever I get one that matches, I'm going to stop right here so I get all of the other ones in there. Yeah.
Oh, does that stop? Does that keep going into the negative too?
No. So this one, we don't know what n is, so that makes it a little weird. We're pushing n towards infinity, so theoretically I can subtract as much as I want. Yeah. Yeah. And we're pushing it towards infinity, so I would want to list a lot of terms out. Theoretically, I wouldn't be able to write that one like forever. Usually they do like a times ... 1. Why? All right, what can I cross out? 3 to the n. Stop saying 3n. Sorry, it reminds me of like when my Algebra 1 students call this like x5. I'm like, that's not what that's called. All right, what else can I cross out? All right.
Can you just say equals infinity?
Theoretically, I like a rewrite step just in case, but I'd be okay. All right, what is this limit going towards? Infinity. Why do I care? That's definitely bigger than 1.
Diverges by ratio of
Yes. I want to know what that limit equals. Yeah. Be real explicit. All right. Now we're going to do the next 2 problems and we're going to take a solid break. I'm going to tell you this one does not work. We're going to talk about it though. I'm going to actually do it so you can 1, see how to deal with that -1 to the n. 2, there's some good limit properties in there. But 3, notice that this is not the same type of function that we were dealing with. These are more so kind of like n to some powers. What would be a good test to use for this guy? alternating series test, that's what we're going to use in a second, so you can start remembering that one. But I want to show you what would happen with ratio test here. Now, for ratio test, I like when it's in one fraction, which is why I extended and curlied that fraction bar. So I'm going to use that as one fraction here. All right. So I'm going to start with my n plus 1th term. Putting n plus 1 everywhere there's an n. On the bottom, I'm going to simplify it into n plus 2. Flip it. All right, let's talk about these -1 to the n's. I think they're dumb. I want to get rid of them because what are they going to cancel into? I have -1 to the n plus 1 and -1 to the n in the bottom. They're going to cancel into -1. Actually, regardless of the power, they're either going to cancel into +1 if there were even numbers of -1s left over, or -1 if there were odd numbers of -1s left over. What's on the outside of this whole set of fractions? Absolute value bars. So regardless of how those cancel, the absolute value of whatever they cancel into is going to be the absolute value of -1 or the absolute value of +1. Those are both 1. So though they have to be here when I set them up, what you're probably going to notice in my work is immediately they're going to go away. I know they're canceling into -1 here, but the absolute value bars are just taking care of that. I really don't need to deal with it. All right. The next step I'm going to do is I'm going to switch some stuff around. Now, we're multiplying, so I can change the order of multiplication, right? That's legal. 6 times 5 is the same thing as 5 times 6. Bonus points if you know what property that is. Commutative. Great job. All right, so I'm switching the order. So I have things that look like each other in the same fraction. All right, what's someone's favorite color?
Oh, yeah, guys.
The red circle. As n approaches infinity, where does the red circle go?
0.
All right, I'm going to give you about 5 seconds to rethink that answer and be very confident about it. I want to hear one number. I'll hint number. Where does the red circle go as n approaches infinity? 1. Same power, top and bottom, ratio of coefficients, 1/1. There's a limit? Yeah, there's a limit. All right. All right, ready? Blue square. As we take the limit as n approaches infinity, where's that one go? 1. All right, easier question. What's 1 times 1?
Oh, this failed.
Ah, Hannah, what did you notice? Yeah, our test fails. We've literally learned nothing. So I wanted you to see what one looks like when it does fail. Notice that I know square root of n's not like an actual polynomial term, but think of like n's to powers. Those don't do well with like canceling like our exponentials and our factorials do. They kind of just give us these situations where we have just things over the same types of things. So those are never really going to be great for ratio tests. The things that are going to give us stuff left over with this n plus 1th term idea are things like factorial, things like exponentials. So those are the types of functions we want to use, not these types of functions. Before we do the last question and go to break, let's just remember alternating series test because you guys said that would be a good one. That was the one with the sentence. It starts with the term since. Does anyone remember where to go from there? Terms. Hold on. Alternate. Do they alternate? How do you know? -1 to the n. Perfect. Decrease in magnitude. What did that mean? What does the in magnitude part mean? Regardless of sign, whoever said that, that was a really good way to say that. So if I look, thinking about plugging in bigger and bigger values for n, do you think that the denominator is going to be getting kind of bigger faster than the numerator is? Yeah. And what was the last one? The limit of what? Of what? Like the... All right, yeah. So this guy without the alternator in there, does that limit equal 0? Which one has a bigger power? The bottom. So does this limit equal 0? Because we're doing a different test altogether. All right, so this guy, do you agree that limit equals 0? All right, so this guy now converges by alternating series test. All right, so you want to be careful and use ratio test when it is applicable because you don't want to have to go and do a whole new test. The test fails literally means absolutely nothing. So you have just wasted time. You haven't gained any information. All right, I want to do this very last problem, and then we're going to take a greater than 4-minute break. This is a last and kind of very special application of ratio test because you get to compare the series to itself. Has anyone heard of recursion or the word recursive before? If you have taken a computer science class, you probably have heard of a recursive. All right, I'm going to write an example of a recursive series of numbers. Oh, well, a sequence of numbers. Let's see if you know the name of these. Anyone know the next number? 34. It is. This is Fibonacci. Can anyone explain what's happening here? Yeah, you add the numbers from before, so I would add these to get to the next one. So what a recursive formula is essentially you need information from the term before to get stuff for the term after. So notice here, to get the n plus 1th term, I need to multiply the nth term by something. This is really kind of, without ratio test, a useless way to define a series. Because if I want to say, no, the 100th term in this series, I would need to know terms 1 through 99 to do that. Mathematically, that's really annoying. Usually I want like a function and I want to be able to say, okay, I want the 5th term, let me plug in 5 and get a number. Well, with ratio test, remember the ratio of things we were doing. So this is me copying the rule from the front page. I'm not like being clever here. We were doing the n plus 1th term over the nth term. I realized that most of the time we flipped and multiplied by the reciprocal, but we're really dividing by that nth term. Well, look at how cool this is for recursive, actually, because a sub n plus 1, I've got a formula for that. So let's just plug it in. So that's equivalent to 2n plus 1, 5n minus 4, a sub n. I'm going to copy down the all over a sub n. What super horrifically convenient thing happens? Literally cancels out. And I just get the limit of this fraction. Are we all comfortable with 2/5? All right, as I write down 2/5, why do I care? So what? Bye. Cool. All right, we're about 2/3 to 3/4 of the way through the notes. So when we come back, we're going to talk about root test. If you preview, though, look at the conclusions. Do they look familiar? Yes. So I'm not adding new conclusions, just a slightly different alternative to the limit. I would love to. All right, let's take 5, not 54. On the test about the test. I mean, for your general life, I would say for your general life purposes, probably not, but I think it's fun to add up infinitely many numbers. Another graduation speech. Is anyone submitting a speech today? I'll just give it to you on your way. What was I doing? Taking a I don't know who drew Judy. Pearson drew the expo marker. I think Quinn drew some of the stuff in orange. We were trying to teach Pearson and Aiden calculus. Literally right there. Why are you in here? Can you do calculus? And you're not welcome in this room.
And you're not welcome. Can you do calculus? Yeah.
Oh, that one. Yeah. Who else? Not. Only two people know.
I forgot
I swear, the further and further we get into the year, the wilder this hallway is getting. I mostly keep the door open just for like entertainment purposes. Someone started singing the YMCA last block. It's in the bathroom. Yeah. They were like, YMCA. We were like, okay. Cool, bud. Like everything except the 3 at the very end. I would compare your powers of N. You might have missed. No. I knew I wanted to do math. I've liked math for a very long time. And then I started thinking about what you could do with math. And I had a couple of jobs, well, mostly one job where I kind of sat behind a desk and I hated it. I like talking to people. And I like high school math a lot. Just the content in general is cool. So I like working with people. You guys make me laugh. Where else can I say I got mad because someone started singing YMCA in the bathroom? I know, my husband is always like, oh, I love working from home. I'm like, I would die. I would die. Oh, and like no fault to people who do, like it's great. Now we can have a dog because he works from home. But all right, y'all ready? I'm gonna get these 3 done, then we'll be done for all of our convergence, divergence tests. So last test, easiest test, not really. Last test, relatively easy test. All right, first of all, same conclusions. Same limit as n approaches infinity. Still comparing to 1, still less than 1, converge, greater than 1, diverge, equals 1, we have failed. The only difference is the innards of the limit. So what we're going to be doing is taking an nth root, hence the name root test. So as you might predict or see from some of these questions, anyone see some patterns within the questions here? All right, a lot of exponents, and specifically exponents that involve the letter n. Oh, fun fact. Have I told you what this is called yet? It's called a power tower.
That's not a power tower.
Power tower. So what we're going to do is if we see powers of n, specifically that n to the n, this is a good test to use. So we are going to take the limit as n approaches infinity of the nth root. There are absolute value bars in there. Those are pretty important because that nth root, we can't like even root negative things. So those absolute value bars are helping us with that root. They are very obnoxious notationally. My eyeball does not like those there, but I know I'm not loving it. But they got to be there. All right. So this question is kind of perfect for root test. No, nope. Just that this is a principal root, so it's only the positive one.
How do you know when to use the root test versus the ratio test?
So ratio test is good for things that are like exponentials where the base is a number. So notice we have like 3 to the n, we have like 2 to the n. This one is good for things that are like this guy, or in this case, I'm using it here because like everything's already to the n power.
Okay.
Ratio, also a big call out is the factorial.
Okay.
Yeah. Geometric only works when my ratio is a number. This one has n's in it. Good notice that we're doing, so this is a backup to geometric. You could use this test for any geometric series test instead. All right, what is going to happen with this nth root and nth power? Effectively cancel. So I'm going to get the limit as n approaches infinity of absolute value bars are staying. All right. I'm going to ask this question again. No one better get this wrong.
One half.
You can hover. What is this limit equal to?
1 half.
1/2.
Less than 1.
Less than 1 converges by root test. In the middle of you guys taking this assessment, all of a sudden I just see everyone.
Yeah. We're watching you just like.
All right, let's make this a little bit harder. So mostly we're going to be talking about how to deal with some weird exponents. Notice I think for root tests, I'm really looking for things to the n power or things with like just weird exponents that have n's in them. So I'm going to try to rewrite this as I go, just to save a little bit of space and time. So I've got, yeah, this one is alternating. So this one, I could use alternating series test, maybe. I'm not super sure which one grows faster though, 7 to the n squared or n to the n. My money would be on n to the n, but you never know. Mm-hmm. All right, I'm gonna roll with this as my guy. All right. Before I even start messing with the exponents, let's see if anyone was listening earlier today. I want to cross out something. Anyone think they know? I want to get rid of that -1. Absolute value bars, I don't care. You're either -1 or +1. Absolute value it, you're gone. All right, now this test was really easy when I had everything like to the n power, like this last one that we did. So I kind of want to get it to that space. So we have to kind of break up our numerator and denominator. Anyone got claims for either what goes in the numerator or denominator? Ooh. This is what Gerben claims, if you write. Specifically with the 7 to the n. Is that right? Yeah, because what do I do to those exponents? Multiply them. A lot of people want to put 7 squared. That would give me 7 to the 2n instead of n squared. So you got to multiply those exponents, 7 to the n. Nice, Griffin. All right. So I'm going to cancel this root with this power. All right. This one I am convinced of what grows faster. What are we thinking? 7 to the n or n growing faster? Exponential. So where is this limit going towards? Infinity. Why does it diverge? Remember, I'm reading your test. I'm dumb. I don't know anything. I don't know how big infinity is. I'm acting. I know I'm not dumb. All right, yes. So this thing right here has two possible values, right? It's either -1 or +1. With these absolute value bars, if I absolute value both of these, they are the same thing. They're just 1. So I'm just going to disregard it. I need to put it in my initial setup. I can't just disregard it that hard. But it's not going to change my answer at all. So I like to get it out of there because it looks confusing. All right, last one. Last notes question of convergence divergence test. I feel like this year I didn't sell it. You guys did not buy my sales pitch. But no, this one actually, a lot of people usually say this is their favorite unit.
What? How?
I don't know. Maybe I taught it bad this year. It's probably my fault. All right. I want to do this the same way. So I'm not going to write the original because there's no -1 stuff to deal with. I want to write it in this to the n form. So ponder what goes in the top, what goes in the bottom if I'm trying to pull out that n power. E squared over n. Again, we're multiplying powers, so e squared up there. All right, I'm going to cancel the n power and the n root. So those are going to go away. Simplifying my process. Oop, I don't need to write that anymore. All right. Ponder very carefully. Where does this limit go?
0.
Why 0? E squared. It has a power of 2.
E is a constant.
Yeah, e is a number over infinity. We get 0. Why do I care?
Less
So what?
converges.
By?
By right root test.
Rashad's really got the script down. Well, I asked all those questions, so those are the questions you want to ask yourself while you're doing it on the test. So as we finish up today, we still have about a little under half an hour. I am going to give you a notes check because ratio test in particular, that is the most important test that needs to come out of this unit. Why? We do something called interval of convergence for Taylor series. It's essentially finding a domain for that. You use ratio tests to start that process. So one section 9.2, literally the notes will be 3 ratio tests, and it will take us all class to do that. There's a lot going on, but it's the biggest one that has to come out of it. All right. As we are moving towards your assessment on this unit, I wanted to give you some resources and some kind of advice as you start practicing. Also, on your problem set, there's a typo. We'll talk about that in a second, but I would get your problem set out. If you don't have these dates, we need to talk. So your problem set is due the next time I see you. If you have not opened that, you need to. It is not a short problem set and is not one that can get done quickly, but very valuable for practice. I am trying to shorten the 9.1 notes as much as possible. I will guarantee you 20 minutes to work on your problem set next time. I'm trying to push it for 30 if I can get the notes shorter. So guaranteed 20 minutes. I'm going to try to push for 30. But that is going to be due the next time I see you. So please, please, please work on it. Send me pictures. I'm probably going to be just in my house all day Saturday looking at the weather. So I'll be on my email. Just let me know. Yeah. Assessment.
Graduation test. Does that do like 12 p.m. tonight? Or
Sure. Are you going to submit a speech? Nice. We have like 7 so far. I'm actually really excited. All right. Then for your assessment, so I'm going to use the word assessment to talk about this test on all the tests. That's going to be Thursday of next week. Now, if you do not study for this test, you're going to have a bad time. And when I say study, I mean do problems. Don't just look at your notes. I don't want to see anyone just staring at their test. Please, please, please. So some resources and some advice about studying for this test. In general, this gets better the more you do. And please don't rob yourself of that first initial step of trying to figure out which test to use. This test is probably, again, going to have a 3 highlighter system where one of the colors is just like you are doing the wrong test. But please don't make me use that highlighter on your paper. So even if you don't do a ton of problems from start to finish, I think a really valuable way to start studying is to look at a list of things like this and be like, okay, which test would I use? You can kind of run through it in your head. The only big one I would practice looking at your quizzes would definitely be that integral test. Some of your integration is a little rocky right now, but we can already see some of the ones here. Yeah.
So E and F are pretty similar, but how do they differentiate?
So E and F, I would actually use the same test for personally. Any thoughts on what I would use for E and F?
No,
I would compare to a P series, and I would probably use limit comparison because the fractions are so complicated. Other things about this upcoming assessment, there will no longer be the requirement where you have to use all of the tests. So for example, I really don't like direct comparison personally, so I just wouldn't use it on this test unless the kind of inequality were super obvious. So maybe like letter C here, I might use direct comparison because it's super obvious there. So lots of practice. If you're looking for some of the practice like on your problem set where we're talking about the error bound and all of that stuff, there's more practice here. Full answer key. Also, if you're having problems kind of putting everything together, I found a couple of flow charts on the internet that kind of summarize everything that we've been doing. If you use this first one, just ignore the part that says Taylor series. You don't need to look at that. If you're a Harry Potter fan, here's a Sorting Hat themed one. That can be a little helpful when you're starting to choose your series test. If you want a actual metric crap ton of questions, these are all here. At some point, I made an answer key to all of these. I will say, getting towards the end, some of these are like way too complicated. But if you're looking for some practice, some of the ones in here that look simpler aren't too bad. And I've like pulled some of these for test questions and for problem set questions. Like this one is one on either your problem set or the notes that we just did. So other things. Does everyone have their problem set out? All right, if you do, there is an answer key. No. There's a typo. Does anyone see it? Yeah, K. There shouldn't just be a random K in there. I wanted all the letters to match. So do you want? Let's make them all Ks. Yeah, I'm gonna make them all Ks. All right, so I wanted all of those to be Ks. I didn't want one of them to be an N, I don't think. So don't say that, ma'am.
I was just, there were 3 K's. Like, I was just.
There are 4.
There's 4 Ks. Okay. So.
Okay. All right, so just make sure as you're doing that, I did want all of them to be the same letter. If you change all of yours to N's, that's also fine. Just I wanted them all to be the same letter. All right, so I'm going to hand out your notes check, and that's the only thing I need from you before we leave today. I will guarantee there's 1 root and 1 ratio on there. Please make sure that you don't cancel weird. Any kind of questions, concerns before we end the together part of class today?
Nah.
We're all
So like for the root one, you literally just add up. I just realized. Oh yeah. That's just where we're all. It should be called radical.
No,
No, I feel like radical. I love that radical. It's the rad. Oh, how did I know that? How did I follow? Oh, the rad. The rad. You know how. You know how. No. Look how close that was supposed to follow. It's like that. What is it? When you broke it apart, what is happening on the back? That's what mine do. In Richmond, it was like, so we were all meeting with the students. Oh, I look at all the schools we were at. They're like in a city. We're like in competition. I'm on the bathroom. Yeah, so we go. And you oh my goodness. So like, oh my God. All right. I need them before you leave.
Oh, dude.
There was so much like yeah, we ran across the street to the lodging place, and then we just brought it back.
Oh, that's smart.
So the what?
And everyone just eating things that stupid.
Version.
And then
Anybody got D?
Oh my God.
How do we know which one was
Huh?
what?
No, I got D.
Do you promise?
How do we know which one we're supposed to use?
I don't know this stuff.
Does one of them have a lot of stuff to end powers?
This one does.
Then I would use
Your 2001 is 99.
Yeah, this one you do your test because there's multiple stuff in the end power.